Hey, what's up everybody? This is the Helpful Hacker, and today we are going to go over the Wireshark The Basics room from TryHackMe. So we'll jump right in and get started with task number 1. You'll want to start your machine, and then up here they give you a quick definition of what Wireshark is. It is a packet analyzer tool. So what it does is you turn it on and it can capture network traffic, and then it saves it all for you and you can analyze it and look through it and see what happened. And it saves it in what's called a PCAP file, and that just stands for packet capture. So a lot of times they'll refer to it as that. What else? This room also recommends that you have some basic networking knowledge. So make sure that you do. If you don't, like if you don't know anything about networking or you don't know anything about the OSI model, check it out. TryHackMe has a bunch of different rooms for it. I have walkthroughs for most of their fundamental level rooms on my channel, so you can check those out there. And as long as you have that, you should be able to cruise through this room and learn how cool Wireshark is. And then the last note that they give us is they give us 2 files. This one, and this is the file that they use to take all of the screenshots that you'll see as you go through this room. But the exercise file, that's the one that you will be using to answer questions. So I am only going to be using the exercise file. So keep that in mind. And then with that, we are done with task number 1. Now it's on to task number 2, tool overview. Okay, so this next section, basically just going to tell us a little bit about the tool. So why would you use Wireshark? Because it's super helpful, but because a lot of times you're going to need to be troubleshooting a network, or you're going to be investigating a network, or you're going to be looking for anomalies, things like that. So if you're in computer forensics, if you're in pen testing, if you're in IT, doesn't matter. Pretty much anyone who does work with computers, Wireshark's useful, right? If you're in IT, you might be troubleshooting a network. If you're in pen testing, you might be analyzing a network so you can find ways to attack it. If you're, a SOC analyst, they should be very familiar with this because they'll want to analyze it to see if there's any threats. So super useful. They mention here it's not an IDS, which is an intrusion detection system. So basically, it's not going to analyze stuff for you automatically, right? Wireshark, the whole point is it captures the traffic, and then we, the actual human being, has to look through it. Intrusion detection system will usually automatically analyze traffic and then send out warnings saying, hey, this is suspicious. So there's a difference there. Make sure you recognize that. And then it's going to tell us a bit about the graphical user interface. So if we look here, we have the toolbar. This is just going to be our main toolbar. We can start collecting traffic, stop collecting traffic, and there's a bunch of shortcuts and stuff. And then if you ever got to access anything, you can usually get it up in the toolbar. So that's always one way to get somewhere. Then you have the display filter bar. This is important because when you get a PCAP file or when you capture a lot of network traffic, it's a lot. And so you need to be able to filter it so that you can find what you're looking for. So that's what that does. Then you have a recent file thing. So if you just had been looking at something, you can open it up again. Then you have this capture, filter, and available sniffing interfaces. So this is for actually capturing. So when you are doing this on your own computer, if you're capturing traffic, you have to decide which interface you want to capture traffic on. And then you can also filter what you capture, which is really useful because then you don't end up with these huge, massive files. If you're looking for something very specific, you can filter that at the capture level rather than the display level. And so your files will be a lot smaller, which is nice. And then at the bottom, we have a status bar that tells us a little bit about the network traffic we have and some other stuff. And you'll learn more about that as we use it, because we'll use that quite a bit throughout this room. So then the next part is loading PCAP files. So let's just do that. So you'll just want to open Wireshark, and then we can go to File, Open, And like I said, I'm going to be using the exercise PCAP file for this. So we'll just open that. And when you do that, you have the file name. This in the middle is all of the actual packets that you captured. Then if you select one of these, so like right now, none of them are selected and these two panes at the bottom are empty. So if I select one, on the left-hand side, I get packet details, and I can look at each layer, and we'll get more into that in a bit, of the packet and see the details. Now on the right-hand side, this is the actual bytes of the packet. So if I click, let's just go up here, I'll click something that hopefully you're familiar with. Let's click the destination MAC address. So it'll actually highlight on the right-hand side, we can see that highlights the bytes that actually correspond to that MAC address. And then I can select the source MAC address, which we can see comes right after. So you can see that move on the right-hand side. So that's useful. So like I said, packet details here, the packet bytes are right here. Then at the very bottom, you have the file name, total number of packets versus displayed number of packets. So that's useful when you actually start displaying stuff. Right now we have 100% because we don't have any filters up here. But when you start filtering, you can see that. So make sure you read through all this. The packet byte pane, that's hex and decoded ASCII representation of the actual packet, right? So on the left side is the hex, right side is the decoded ASCII. Let's see. So yeah, mess around with this. That's the best way if you're learning how to use a tool. Just mess around and play with it. You'll learn quicker than doing anything else. So coloring packets. So the packets, as we can see, some of them come in different colors based on protocol, and we can change that if we want. So there's a default that comes with it. For the most part, that's fine. So you can go to View, Coloring Rules, and permanently change it. So that means the next time you open Wireshark, the color rules that you set are going to be there. You can also temporarily change it, but we'll talk more about that in task number 5. And I personally think that's a bit more useful, and most people just tend to leave the defaults unless you get really into Wireshark, like maybe if you want to be a network engineer or something. I'm sure they probably get really into having their own color coordinated rules. So you could do that, but it is helpful. It helps you view the traffic differently and being able to recognize things quickly as you scroll through. So that's coloring. Next is traffic sniffing. So network sniffing, that can usually just be done by hitting the start capture packet up in the left-hand corner. It looks like the blue fin right here. So I can stop capturing traffic when I'm done. I can restart a capture. So if I start a capture and then I don't like something, I can restart it and start again. And then there's some other options in here as well. We won't get too into them. You don't really need to know them to do this room. As you keep using Wireshark, you'll learn all of its features. And then up here at the top, when you do start capturing packets, it'll tell you what interface you're on up here. And then it'll give you packets displayed and let you know down here there is a live capture. So those 4 buttons up at the top left are the ones you'll most commonly use to capture traffic. Next, they're going to talk about merging PCAP files. So let's say you have multiple packet captures and you want to merge them and analyze them together. You can do that pretty easily. You go to File, Merge, and then you select which one you want to merge with. Now what's important here is if I go to File, I'll show you here because it's easier to see. Merge, and I'll just select that. So what is this merging with? It's merging with the current packet capture that I have open. So I'm not going to actually do it, but if I did that, it would combine HTTP1 because that's the one I've selected, but it would also combine exercise.pcap to it because that's what I have open. So that's how that works. Pretty straightforward. So if you need to merge files, you can. And then view file details. So there's really two ways to do this. You can go to statistics, capture file properties, or at the bottom left, there's a little button that you can click right down there, and it'll give you the capture file properties. So there's two ways to get there, which tends to be the case. There's usually always a way to get to whatever you want to get to up here, but a lot of times they have little shortcuts. So that's how you see file details. Now down to the questions. Let's see, read the capture file comments. What is the flag? Okay, so capture file details. What are the comments? This is not a flag, this is not a flag, this is not a flag. Go to packet number 39765. Wow, this seems excessive. Is this just the first question? What is the flag? Okay, so here's all the packet comments. Did they even tell us? No, they didn't. Okay, so this is one way to get to the comments. I don't think they really talked about comments, did they? Is there something I didn't click on? Nope. Okay. I guess they're just throwing you into it, man. Great. Love that for me. So here are all the packet comments. Down here it says go to packet 39765. Look at the packet details pane. Right click on the JPEG. So do they really want us to do all this in the first question? That can't be right. Oh, these are packet comments. Okay, I was being stupid. And the flag is right above it. Oh my gosh, that's embarrassing. Okay, well, hey, you live and you learn, right? So I was looking, so in here you have file comments and you have packet comments. I was looking at packet comments, which clearly at some point they're gonna want us to do that with. But no, they just want the file comment. Man, basic reading comprehension, what a struggle. That's not what I copied. TryHackMe Wireshark demo. I missed the T there. Okay, that makes more sense. I was like, that seems excessive for the first question. So that's the flag. Be smarter than me and look at the file comments and not the packet comments like it tells you to. Okay, now what is the total number of packets? That's probably somewhere in here. Packets. 58,620. So submit that. That's the answer for that question. What is the SHA-256 hash value? SHA, here are some hashes. Here's their 256 hash. Don't want them, whatever. Clearly terrible at highlighting things, but who cares? So that's the answer. All of that was found in this capture file properties thing. So go through that, answer the questions, and with that, you're done with task number 2. Now it's on to task number 3, packet dissection. So basically, now that we've focused a little bit on the overall, now we're gonna dive really deep into this bottom left pane and how it works. So like I already said, you can click on stuff and then it'll show you down here at the bottom. Let me minimize all these so we can see better. And then we can look into each one of those real close. So that's what this bottom left part is for. That's where you really inspect the individual packet. And then make sure you read through this. It's going to talk a little bit about the OSI model, and we're going to go through each layer down here. So don't worry too much about it. We'll get to it. Let's see. Each time you click a detail, it will highlight the corresponding part in the packet's byte pane. We already talked about that. And then let's have a closer look of the details pane. So there's different layers here, which we can see. So let's just pick a piece of HTTP traffic, and we have our layers here. Now, layer 1, what is this? This is our frame. This tells us like actually data about like how many bytes are on the wire, how many bytes are being transferred, and the time between them, right? So time change from the previous capture frame, stuff like that. So this gets really into how many bytes, how fast, all that stuff. So that's the frame. That's the actual ones and zeros being passed along the wire, so to speak. So you'll find that here in this first layer, all that good information. Then after that, you have layer 2, where MAC address. That's what you should always think of when you think layer 2 or of the OSI model. And here you're going to get the destination and source MAC address, which if we copy them, we can see here's our destination, here's our source. If we want to dig in more, we can, learning about each one of those. So that's the MAC address layer. Then we have the IP layer. And this is where, if you know the OSI model, you should know, this is where the IP addresses are going to be. So we can see the Internet Protocol version 4, and we have the source and destination address, and then it tells us all this good information about it. It gives us the time to live, fragment offset, total length, header checksum, stuff like that. So source, destination, pretty cool. So you'll be in the IP section a lot usually. That's when you really get into packet capture stuff, you'll be in this frame layer, but most people, we stick around like layer 3 or later. That's where we look for stuff. So yeah, so that's the layer 3 or the networking layer. Then on to layer 4. Layer 4, this is going to talk about the actual protocol used. So this would be the transport layer on the OSI model. And so in our case, let's take a look here. So they're using TCP, right? They could be using UDP or something else, but we know here they're using TCP. And then it tells us about the source port, destination port. It gives us a sequence number, an acknowledgement number, all stuff that's involved in like the 3-way handshake. We have flags where we can see there's an acknowledgement flag in this packet, stuff like that. So pretty useful. And it also gives us a TCP payload. So that's layer 4. Then we have protocol errors. So that is, I don't know if we have any here. Maybe I can see it up here. Timestamp, payload, segment. Yeah, can't really see it. I'd have to go find a packet with it, but it says 2 reassembled TCP segments, and then it tells you which segments had to be reassembled. So that's a protocol errors section. If you have that, then it'll show up. If you don't, it doesn't show up. Again, with like, for example, here we have the hypertext transfer protocol, so HTTP layer. But if I click on TCP, then that layer is just not there. So sometimes that's the case, but read through that. And then we have the application protocol, layer 5. So in our case, for the most part, it's going to be this HTTP. And this is going to talk about all sorts of good stuff. Or sorry, that's still transmission control. I need to get on an HTTP packet. Here we go. So hypertext transfer protocol, we can see it's a GET request to this long string, host, user accepted language, a lot of headers that you would normally see. And we can read about all that. So that is what you would find there. Then you also have application data, and let me show you what that looks like. Here we go. Oh, hey. So with this, we also can go back and we can see our reassembled TCP segments, right? Like the example they had. So that goes back to this little spot. So we found a packet that needed to be semi-reassembled. So after the protocol here, this layer, we can look and we have line-based text data. So text/HTML, and there's 3 lines of it, right? So this is like the actual application data that's being sent. And if there is some, you'll have this section. If there's really not any, then it'll just look more like this, and you won't have that yet. So read through all those, make sure you kind of understand them, and then we'll do the questions. So view packet number 38. Where are you, 38? 38, awesome. Which markup language is used under the HTTP protocol? So that would be the extensible markup language. Submit that. Right, and that's because it's just right under here, underneath that HTTP. And then we can see the actual XML. And then what is the arrival date of the packet? An easy way to find this would be in Hypertext Transfer Protocol. We can actually see the date. So I believe May 5th month, so 5/13/2004. Sweet. Then what is the time to live? I believe that would be in, fun little quiz, Internet Protocol. Time to live 47. Because Internet Protocol is part of the routing and IP addresses, so that would know how many hops before the actual packet should be abandoned. Now, what is the TCP payload size? That would be in the Transmission Control Protocol section, because that's TCP. So let's see, where is it? Payload, 424 bytes. And that looks right. What is the E-tag value? I don't know what an E-tag value is. Is that something I should know? Probably. Maybe it's a header? Oh, here we go. E-tag value. So I assume they want this long thing. So submit that. I'm not sure what an E-tag value is, but I figured it was probably in the Hypertext Transfer Protocol just because we have all these headers and I don't know all of the HTTP headers. And yeah, it didn't sound like something that would be, because the frame and Ethernet layer are pretty straightforward. More often than not, they either want a data amount or they want IP address, MAC address, that kind of stuff. Transmission control, that's where you're talking about ports, more about IP addresses actually in that layer and other stuff. So I just kind of guessed. I happen to be right. But if you don't know, I mean, you could just keep looking through it and you would find that E-tag value. So that's where that's at. Once you've answered those, you're done with task number 3. Now it's on to task number 4, packet navigation. So there's a few ways to navigate through packets. So you can navigate using these numbers, which are they not showing? Oh, no, they are. Nope, I want to go by numbers. Yeah, so we have packet numbers here on the side going from 1, and it just goes up based on, the order that they came in. And we can use this go to packet feature, which is really nice, especially if you have a lot of traffic. Go to packet, and then you could just like type in the packet, hit enter, and it'll take you there. So that's important. So you'll go up there, go to packet, type it in there, and then it'll highlight it for you in the window with all your packets. So find packets. So you can do this a couple of different ways. You can go to edit and you can do find packet. And then what'll happen is this search bar that they have highlighted in red will pop up. What I tend to do is I just click out here and then I hit Control F and that'll give me the exact same thing. So that's just the hotkeys for it. But that one is one you'll probably be using a lot, so that's useful to know. And then we can look for things based on different stuff. So I can look in packet details, or I could look in packet bytes, or in the packet list. You'll tend to stay in packet details. And then let's say I'm looking for a string. So I could do hello. Let's see if any packets say hello. Oh, there was one. Oh, I guess that makes sense because of the TCP handshake. Or no, this is actually a TLS. So this is encrypted stuff. But we can see client hello, and it even highlights where it found hello for me in the details. So that's pretty cool. So, and then if you are done searching for stuff here, you can just hit cancel. It'll get rid of that. But yeah, so those are the two ways to find stuff, and you can find it based on multiple things. Let me go back. Not just strings. You can also do hex values, display filter, or regular expressions. Generally, you'll be using these two. Regular expressions is just like a really nice way to search for stuff, or you can just do it based on the string. And then don't forget, over here you can pick where you're looking for it, and most often it'll be in packet details. So that's a way to find packets. Again, I'm just going through these, but make sure you read everything they have written down. It's helpful. And then what you can do is you can mark packets. So you can right click on a packet and you can mark or unmark it. You can also go to edit and then do mark and unmark. Same thing. Right clicking tends to be easier. So if you find a packet and you're like, oh, I got to remember this packet, you can just mark it. By default, it'll mark it black. And then let's say you change your mind, you can unmark it. And that's unmark. There we go. And that's really useful if you're going through and taking notes and trying to keep track as you're doing analysis. Another thing you can do is you can make a packet comment. Again, you can go to edit and find that packet comment, or you can just right click and make a packet comment. So we'll make one. Where is it? Packet comment. There we go. And I'll just say first, because it's the first packet. Then I hit OK. And then what happens is if I travel back to that, now I see I have this extra layer that gives me the packet comment. So we can add comments to these as we're going through and doing our analysis. So hopefully you can see, you mark a packet, you comment it, lots of different things to help us analyze what's going on. Another thing that we can do is we can export packets. So why would you want to do this? Because sometimes you might have a ton of network traffic that you've captured, and let's say you find the conversation that you're looking for, or let's say you find you narrow it down and you have the IP address of whatever you were looking for. So you can actually just then export those packets that you really want to focus on. And so it just helps you narrow down what you're working with, which is a big part of using a tool like Wireshark, because there's just so much network traffic. The hardest part is finding things and getting stuff narrowed down. So that's why you may want to export a packet or a group of packets. So you can do that just by going to File, going down here, and you have multiple export options, but you can export specific packets. So that's cool. Another really useful thing is exporting objects. So as you can imagine, as this traffic was being made, people were sending things to each other, like messages or files or whatever, right? So with Wireshark, because we captured all the traffic, and if it's all readable, in this case it is because it's HTTP, we can export objects, and then it gives us options. In this case it's HTTP, and we can actually recreate a lot of these things if there's a file. So here you go, note.txt, we could export that, and then we would actually have a copy of what was sent, which was note.txt. So that's really useful. And this works with selected protocol streams. So these are the streams that they have on there. And then if you have those protocols, you can export objects from them. Another thing they show you is the time display format, because the default time display just tells you how far apart the packets are in seconds. But a lot of times, especially if you're doing forensic analysis or something and you need to know, how long or how far apart were certain things based on date, you can use the UTC time display format. And to do that, you just go to View, Time Display Format, and then you can select. So that's useful, and you'll need to know that. Then they talk about expert info, which is pretty cool. So you can read about it here. So it has different severities for different things. Yeah, so you can read more. There's a bunch of documentation about this expert info, but basically it helps highlight certain things for you in the most basic form. That's the way we'll be using it in this room. And what you can do is you can just click that little red button, and then it gives me a summary of all the packets. And I can see there's a comment, there's 13, there's 2 that were malformed, right? And then I could hit show, or can I not just open them? Oh, I don't know. I'm sure there's a way to. I'm just not. Oh, here we go. Okay, so then we can actually see these are 2 malformed packets, right? And so it gives us all of this info, and it color coordinates it. So make sure you read through this so you can understand what those colors mean and what the difference is between a chat, a note, a warn, and an error. And yeah, so there's 2 ways to get to that. Like I showed you, there's the little button at the bottom, or you can go to Analyze and then do Expert Information, and it'll bring up that same window for you either way. So that's helpful. So now down to the questions. Search for the R4W string. In packet details, what is the name of artist 1? So packet details, again, if you weren't already here, I like to just Control F, or you can go to, I believe it was edit. Yeah, so it was edit, it's edit, find packet. So if I don't have anything, I can do that. I usually just like to click and then hit Control F, and this little window will pop up. So I'm in packet details, and I am looking for R4W, and that's a string. So I'm gonna hit find, let it run for a second. And here we go. And it even does me the favor of lighting up what I'm looking for specifically. So we have the artist 1 equals, and then there's this header, and it says this R48173, or excuse me, R4W8173. So we just got to add 8173 to that, and that's the name of artist 1. And I knew that because right here, what this is this is some HTML. And so if you can read HTML, you know that that is probably referring to the artist's name. If you don't know that, don't worry too much. You should check out TryHackMe. They got rooms on like web application stuff and HTML, and they have more detailed rooms on HTTP and even JavaScript. So you can check those out. But that's how I knew that that would be the answer. So that's the answer. Submit that. Then down here, go to packet 12 and read the comment. Okay, so what I can do is I can do go to packet, and then type in 12. Great, now here's a packet comment. Let's go to packet number 37. Look at the packet details pane, right click on the JPEG. Okay, so the other thing you'll see here is like the view on this. I can't see everything. So I can't see that whole comment. So what I can do is I can just go up to the capture file properties and read the whole comment, and it looks cleaner just right down here. So it wants me to go to this packet. It wants me to look at the details pane, click on the JPEG section, and export the packet bytes. And it tells me this is an alternative of extracting data from a capture file. Then what is the MD5 hash value of the extracted image? Okay, so I copied that number. We'll walk through this. So first thing I'm gonna do is go to packet, and then paste that number. So this is the packet that I'm looking at. It then told me to go to the JPEG section. So here we go. So we have our hypertext transfer protocol, and then right after that, this is the JPEG that was actually sent. And it told me if I right click on the section, I should be able to export packet bytes. Now desktop, I need to give it a name. I'll just call it ASDF. I'll save it. Now, if I wanted to, I could have gone to File, I could have gone to Export Objects, HTTP, because that's what this was transferred over, and then if I searched for JPEG, I could see I have all these different JPEG files, right? So, and then I have the packet number, so I could do that, and then I could save it, right? I'm not going to do that because I already did it the way they told me to, but that's two ways to export an object. You can either find the object in the details and then export all the bytes, or you can just look at all of the potential objects of the whole packet capture and export them there. So now what it wants me to do is I have this ASDF file, and it wants me to get the hash value. So I'm going to open up a terminal, and then I'm going to do, I think it's MD5 sum, or wait a minute, hold on, where am I? I got to move into the desktop where the actual file is. So now I'm on the desktop, and now I'm going to do MD5 sum ASDF. I think that's the command. Okay, I could have sworn on my life. Is it sum? I thought it was MD5 sum ASDF. Okay, so hold on. I'm in the desktop. If I ls, I can see ASDF is there. So I could have sworn it's MD5 sum ASDF. Is that not what I was typing before? Here, I can find out what I was typing before. MD5 sum ASDF. MD5 sum ASDF. I don't know. I must have somehow typed it in wrong that first time, but that is the command. So this is our MD5 hash of ASDF, which is this image that I just got from the exercise packet capture. So we should be able to paste that and submit it. If you don't know what an MD5 hash is, or if you're not totally familiar with hashes, just keep working through TryHackMe. You'll learn about hashes and what they are, but it's basically a representation of the entire file, kind of. That's the way I'm going to explain it right now. They're used for a bunch of stuff, and as you get into things like John the Ripper, you'll learn way more about hashes. So don't worry too much. Just know the command is MD5 sum, and type it better than me, because for whatever reason, when I typed it right here, I did it wrong. Maybe I added an extra space or something. I don't know. But anyways. Okay. Wait a minute. Yeah, those look exactly the same. That's going to bother me. But on to the next question. I digress. So there's a .txt file inside the capture file. Find the file and read it. What is the alien's name? So let's go back to Wireshark. And what are we looking for? We're looking for a .txt file. So I'm just going to go to File. It's a .txt file that I assume was sent over there. .txt. We have note. So I'm going to click on that. Hit save. We'll save it to the desktop as note. So save that. Then I should be able to just exit out of that. See the note. Let's open it up. Packet master. So here's the note that was sent over the network. So let's take a look. packet master, that's the right answer. Look at the expert info section. What is the number of warnings? So back to Wireshark. I always like to go here. You can go to analyze and then do the expert information. I normally like to just click that little button right there next to the circle. And it wants to know how many warnings do we have. So let's slide over. 1,636. So submit that. And we just got that by sliding over, and we know that yellow, because we read through all of TryHackMe's stuff, is warnings, or it just says it right there. So that's how we got that. And once you've answered that, you are done with task number 4. Wow, we went through a lot. And now it's on to task number 5, packet filtering. So packet filtering, super important. So up here, read through this. This is where they distinguish between capture filtering versus viewing filtering. Because all of this stuff has already been captured, we are doing display filtering. So we're displaying what we see, but we're not changing what was actually captured. If you do capture filtering, then Wireshark will actually ignore certain packets and never even copy them. So those are two different things. You can read more about it from their stuff. And then it tells us a little bit about filters, and then talks about the GUI. And basically, if you don't want to write these queries, because they do get hard to write, and I mean, you should be able to write some basic ones, but if you can click on it, you can filter and copy it. So that's pretty much what they're going to talk about here. We're not actually going to write them out. We're going to click and copy filters. So the way that you do that is you just apply a filter. So you can do that by just right clicking on something, and then I can hit apply as filter, selected. So now it's going to filter out for that IP address because that's what I had selected up here. Now check this out. Let's say I don't want to filter by IP address. Let's say I want to filter by something else, like the source port. So now I'm going to click on that, right click on it, and then I can hit apply as filter, selected. So now it writes out source port 80. So now I'm only getting stuff where the source port is port 80, right? So again, if you can right click on something, you can filter by it. Another way to do that is you can do analyze and then apply as filter, but don't do that. That would be a pain. Apply as filter, selected. Yeah, just right click on stuff and apply it as a filter. Another thing that you have is you have a conversation filter. So what that does is that will not filter just the one thing you asked for, but it will filter anything that interacts with that. So let's, I think the best example is I'll just show you. So here I did port 80, right? And I applied that as a filter. But now, what if I click on this? I'll go to port 80, and then I'll do a conversation filter. Now I got to pick at which level I'm kind of doing this, right? We have Ethernet, we have TCP, IPv4. I'll do TCP. So I just say TCP. And now if we look, so it took that packet and everything up to the TCP layer, it added in this long filter. So now it's having all of the conversations that involve those things. So in order to be a part of this conversation, the IP address has to be this, and the other IP address has to be this. So these two IP addresses are talking back and forth, and we can see that if we just look at these IP addresses. And then the TCP port has to be 80, and the TCP port has to be 3372. So now what we've done is we've captured this whole entire conversation, this back and forth on the TCP layer. Now what we can also do is we could do it at a layer lower than that. We could go all the way down to Ethernet, and we see this here, source address. So that would be its MAC address. And we could do conversation filter, And let's do this on, again, we're at Ethernet 2, so the Ethernet layer. And then because we're doing it at a lower layer on the OSI model, hopefully this is making some sense. If the layers are confusing you, don't worry about it. Just pay attention to the filters. Now we're filtering based on just the Ethernet address or the MAC address. So now we can see, anything that has this and this MAC address, if those are involved in the conversation, we're going to show that packet. So filtering for a conversation is super useful. And again, you can go to Analyze and go to Conversation Filter, or you can just right click. Another useful thing is you can colorize the conversation. So you can go to View, Colorize Conversation up here. Or what you can do is you can just, again, right click, Colorize Conversation. We'll do it at the Ethernet layer and we'll pick color 4. So now you can see that whole conversation is this color. Now let's say I want to get rid of this. Right click, colorization, colorize conversation, Ethernet. What? I can't undo it. How do you undo it? So you can right click and colorize stuff, but to undo it, you have to actually go to Analyze. Or wait, I think it might be View. Yep, colorize conversation, and then you can hit Reset Colorization, or the hotkeys are Control Space. And then when you do that, all the colors are going to go back to normal, right? So that's useful if you want to highlight a specific conversation as you're going through the traffic. Again, multiple ways to do that. And then another cool thing is we have Prepare as Filter. So what this does is it does the same thing as Apply as Filter, but it doesn't hit Enter. So instead, it just fills it out for us. And why that's nice is because that allows us to build our own filters, right? So let me show you. Here, I'm gonna first, let's just apply as filter. So, or wait, I'm stupid. Let me prepare as filter. And so I'm preparing that. So now the IP source address is this. So it just wrote that. It's not gonna actually do it, right? So I still have all of the traffic here in front of me because I haven't hit enter yet on this filter. But now what I can do is I can select something else like this. So let me select this packet, and then I'm gonna actually go to this protocol. So this is the user datagram protocol, or DNS, which uses UDP. And so DNS uses UDP, and what I want to do is I want to prepare as filter and select it. So now what I'm doing is I'm taking that first prepare as filter and I'm going to add this one to it. So now I need this IP address and I want the protocol to be UDP. And so by preparing as filter, we can build these long, complicated filters based on what we're seeing and then submit them when we're ready. And we can see there's only one packet with that. So that's what prepare as filter does. Super useful. It's useful to mess around with. Another thing they have is apply as a column. So any little detail here, I can just right click on it and then apply as column. And now I have a column for the actual source port. What if I want to get rid of that column? I right click and then remove this column at the bottom, right? And any of these columns, you can organize all of your traffic based on that column, right? So that's organized based on protocol. I could organize it based on destination, but most of the time we'll want it just organized based on packet number, because then we get the flow of the conversation. So that's apply as column. Again, right clicking is easier, but if you need to, you can go to analyze and apply as column. Then you have follow stream. Again, we're going to be right clicking, but you can also go to analyze, follow, and then it'll give you in something like the options, and then you can pick which stream you want to follow. So I'll just go to HTTP here. You right click, go down to follow, and I'm going to follow the HTTP stream, and it's going to open up this other window for me. And now I can see all of this stuff. And this is actually what was sent, you know, on the HTTP kind of like layer 7 or of the OSI model, right? And I think it says right here, yeah, so this helps you view the raw traffic as it is presented at the application level. So that's what you're doing when you're following the stream, and it's helpful. It makes things more readable and puts it in a way that we're more exposed to if you're doing a lot of like HTTP stuff, or, you know, burp suite. If burp suite and those other terms don't make sense to you, don't worry about it. Just remember this. When we follow the stream, it helps present the raw data or the raw traffic as it would be seen at the application level, which is very useful. So, but another note it leaves is after you do that, like I said, it'll pop up a new window. This time I'll follow the TCP stream, same deal though. And you got to exit out of that window when you're done. So keep that in mind. Now it's down to the questions. Let's see, go to packet number 4. Oh, wow, look at that. We're already there. Right click on the HTTP or hypertext transfer protocol and then apply it as a filter. Now look at the filter pane. What is the filter query? So number 4, wait, it wanted us to filter based on protocol. So let me just go down here in the details. I'll apply as filter. And there we go, HTTP. That's a pretty easy little filter. So that would just filter by HTTP. And that's how I did that, just following those instructions. Okay, so what is the number of displayed packets? That would be down here in the bottom right. We have 1089. So 1089 displayed packets. Go to packet number 33790. So I'm just going to copy that, get rid of my filter, go to packet, paste that, and then what's it want me to do once I'm there? What is the total number of artists? Okay, so it tells me I should follow the stream. So let me do that. Follow HTTP stream. And then in here, they're gonna have different artists, kind of like what we saw with that first question where it's like artist equals 1, and then it gave us the artist's name. So I'm looking through this, and this is a lot of back and forth. So what I'm gonna do is I'm just gonna use this find feature and do artist and see what I get there. So let's find. And then that's the first one. I'm sure there's multiple, so it jumps through these. This is still taking a while because there's artist is written a lot. So maybe if I find, oh, here we go. So artist equals 1. Maybe if I do artist equals 1, so I'll find that. And then let's try artist equals 2, because that means there's 2 artists. And then let's try artist equals 3. So there's at least 3 artists, and then artist equals 4, and it didn't find me anything. Okay, so I think there should be 3 artists. And again, you could go through and manually figure that out, but that's a lot of scrolling. So I just use this little find feature and it'll just look for whatever I type in there. So yeah, what is the name of the second artist? This is easy because we can just artist number 2, what's their name? Their name is Blade with a 3 at the end. So let's submit that. Sweet, and with that we are done with task number 5. Now it's on to task number 6, the conclusion. Basically, we finished up the room. Congrats, guys. There's additional rooms that TryHackMe has on Wireshark. This is just the basics. You can get really into it and learn a lot of cool stuff. So, you know, keep learning, check out those rooms. I hope you found the video helpful. If you did, please give it a like and subscribe. That helps me out a lot. And with that, we have finished the Wireshark, the basics room from TryHackMe.